polygons. For this subtopic, you just need to know how to find the area, okay? So there are a triangle and how to find the area of the quadrilateral. Okay, for the triangle, you just need to list out all the points, okay? You got triangle, got 3 points, right? Point A, point B, and point C. So you list out the point A, point B, point C, and point A again, okay? Then you times the x1 with x2 plus x2 times y3 plus x3 times y1. Then minus of the x2 times y1 plus x3 times y2 plus x1 times y3. Okay, then you will get your answer. And why got a modulus at here? Because the area cannot be in negative, okay? Must be in positive. For the area of quadrilateral, you just list out all the points. Point 1, point 2, point 3, point 4, and point 1 again. Then you use the formula, then you can directly find your area of quadrilateral, okay? Now got one important point that I need you to remember. If you find that your area of ABC is equals to 0, then you must know that your ABC is a collinear. What does it mean by collinear? That is a straight line. A, B, C. A straight line doesn't have an area, okay? Now got another way of finding the area of the triangle, which we call that a box method, okay? So for this example, we know that the area of triangle is half times base times altitude, okay? We have to find the base got how many units? From 4 to -3. Here got 7 units. And from 1 until 4, how many units? Here is 3 units, which is the altitude. Half times 7 times 3. So my answer for the area is 21/2 unit square. Okay? For another way, you can draw a box. Okay? The area of the box is equals to area of the first part plus the second part plus the third part of this triangle and plus the A4, okay, the area of the fourth part, which is the part that we want to find. Okay, this is the part that we want to find. So, area of the box, we can know how many units square? From 3 to -3 is 6. And the height is from -2 to 4 is 6 units, okay, which is 36 units. Area of the first part is half times, here is how many units? Is 2 times, here is 6 units, okay? So 6 times 2 is equals to 12. 12 times half is equals to 6. Plus the second part, which is this part. So half times, how many units is the height? 4 units. Times the base is 2 units, which is equals to 4 times 2 is equals to 8. Divide by 2 is equals to 4. Plus the third part, okay, which is this triangle. So half times the height is 6 and the base is equals to 4. So the answer will be equals to 12 and plus the area of the fourth part. So I know my area of fourth part is equals to 36 minus 6 minus 4 minus 12, which is equals to 14 units square. Example 1. In the diagram above, A, B, C, and D are the vertices of the quadrilateral. Find the area of the quadrilateral A, B, C, D. So this should be an easy example. So my A, coordinate A is -3, 0. I have my coordinate B, C, and D. So my area will be equals to half modulus -3, 0, 5, 2, 10, 7, and then 1, 8, okay, is equals to 1/2. -3 times 2 equals to -6. Plus 5 times 7 is equals to 35. Plus 10 times 8 is equals to 80. Minus of 0 times 5 is equal to 0. Plus 2 times 10 equals to 20. Plus 7. Okay. So I will get my answer is 109 minus 3, which is equals to 53 units square. The triangle of OBD. The O here is the origins. So the part B, the area of triangle OBD is equals to half times O is 0, 0, B is 5, 2, D is 1, and 0, 0 again. Okay, 1 over 2. 0 times 2 is equal to 0 plus 40 plus 0 minus of 0 plus 2 plus 0. So my answer will be 19 unit square. Example 2, the coordinates of the vertices of the triangle ABC. If the area of the triangle ABC is 12 unit square, find the possible values of K. So we got the area of 12 units. So area of triangle ABC is equals to half modulus 1, negative 2, K6. 1, 2, and again 1, negative 2. So area of ABC is equals to 12. Half 1 times 6 equals to 6 plus 2k minus 2 minus 2k plus 6 plus 2. Okay, so I will get 24 here and modulus 4k minus 4. Since it's a modulus, so 4k minus 4 is equals to 24. 4k minus 4 is equals to negative 24. They've got two possible, okay? They've got two possible conditions. So my k is equals to 7. My k here is equals to negative 5. So I got two possible values of k. Example 3. In the diagram, AB is a straight line. Find the equation of a perpendicular bisector of AB. We have to know what is perpendicular bisector of AB, okay? Bisector means this is the midpoint of AB and this is the straight line, okay? So this is the equation of the perpendicular bisector of AB, okay? Let me give him a name. Here is C, here is D. So the equation is CD, okay? We have to find the equation of CD. So the first thing we have to find is the midpoint of AB. Midpoint of AB is equals to minus 6 plus 4 over 2. 1 plus 7 over 2, which is equals to negative 1, 4. After we find the midpoint of AB, then we have to find the gradient by using the gradient of AB. The gradient of AB is equals to 7 minus 1 over 4 minus 6, which is equals to 3 over 5. We know that the gradient of AB times the gradient of CD is equals to negative 1. So the gradient of CD is equals to negative 5 over 3. Now we can find the equation of CD by using the gradient and the midpoint of AB. Y minus y1 equals to mx minus x1. Y minus y1 is equals to 4 equals to gradient is negative 5 over 3 x minus 1. So I can get my answer is y equals to negative 5 over 3 x plus 7 over 3. Okay, so this is my first part. Then the second part, it wants us to find the perpendicular of the bisector cut the x-axis at point C. Find the coordinate of point C. So it wants us to find the coordinate of C. We know that C is the x-intercept. So that means y is equals to 0. So I will substitute my y equals to 0 into the equation of CD. Okay? So y equals to 0, negative 5 over 3x plus 7 over 3. I can find my x is equals to 7 over 5. Okay? So I can get my coordinate C is 7 over 5, 0. Then we go to the third part. Find the area of triangle ABC. So the third part here, area of triangle ABC. Half modulus, coordinate A is negative 6, 1, B is 4, 7, C is 7 over 5, 0, and go back coordinate A again, negative 6, 1. Okay, I will get negative 42 plus 0 plus 7 over 5 minus 4 plus 49 over 5 plus 0. Then I will get my answer as 136 over 5 unit square. This is the last example of this subtopic. I need you to be more focused because this is a long question, okay? Example 4. 3 points A, B, C are located on a Cartesian plane. Find the equation of the straight line passing through A and perpendicular to AB. So what is the diagram? Let us draw. Okay, let's say this is A, this is B. This is A, this is B. A is -1, 4 and B is 2, 2. Okay, the equation of straight line passing through A and perpendicular to B. So this is the equation that we want to find, and it is perpendicular to AB. Okay, so for this equation we only got the point. We don't have the gradient. So we can find the gradient by using the gradient of AB. The gradient of AB is equals to 4 minus 2 over -1 minus 2. I can get my answer is -2 over 3. Okay, so I can find my gradient. Gradient of AB times the second gradient is equals to -1. The second gradient is equals to 3 over 2. Okay, so I already got my gradient and I got one of the point. So I can use the formula to find my equation. Y minus y1 equals to mx minus x1. Y minus y1 is equals to 4. The gradient is 3 over 2. X minus -1. I can get my answer is y equals to 3 over 2 x plus 3 over 2 plus 4. Finally, I get my equation is 3 over 2 x plus 11 over 2. Okay, let us go to the part B. The equation of straight line passing through the point C and parallel to AB. What will be it looks like? Okay, let me draw. A is here, -1, 4. And B is here, 2, 2. Where is the C? This is B. Okay, C will be 7, 3. Okay, C, 7, 3 is here. Okay, so the straight line, the equation of straight line passing through C and parallel to AB. Okay, my AB is here. Okay, my straight line AB is here. The line which is parallel to AB, which means it is here. It is parallel to AB. Okay, so do I have the gradient of this line? I don't have. But since it is parallel, then that means the gradient is same as AB. So my gradient is -2 over 3. So my gradient of this line is -2 over 3. And I have one of the point. So I can directly find my equation by using the formula. Okay, y minus y1 is equals to 3. Gradient is -2 over 3. X minus x1, which is 7. Okay, y equals to -2 over 3x plus 14 over 3 plus 3. So my equation of this line will be -2 over 3x plus 23 over 3. Let us go to the part C, the coordinate D, where the straight line in A and B meets. Okay, this line and this line meets. That means for the part A, this is the line. Okay, here is the perpendicular. Okay, then we meet here, which is the coordinate D. Okay, this is the coordinate D. So, do I have the equation of the green line? Yes, here it is. Okay, this is the equation of the green line which I find in the part A. Do I have the equation for the red line? Yes, I have. This is the equation that I find in the part B. So, since D is the intersection point of these two lines, so I can equalize these two equations. Okay, so y for part C, y equals to 3 over 2x plus 11 over 2, and another equation is y equals to -2 over 3x plus 23 over 3. So I can equalize these two equations. 3 over 2x plus 11 over 2 is equals to -2 over 3x plus 23 over 3. So I will move the variable x to here. So it will become 3 over 2x plus 2 over 3x is equals to 23 over 3 minus 11 over 2. I will get my answer as 13 over 6x is equals to 13 over 6x is equals to 1. Then I can easily get my y equals to 3 over 2, 1 plus 11 over 2, which is equals to 7. So I can conclude my coordinate D is 1, 7. Okay, let us go to the part D. The area of square ABCD. Okay, now we have to find the area of the square of ABCD. So the part D, the area of ABCD is equals to half. Coordinate A is negative 1, 4. Coordinate B is 2, 2. Coordinate C is 7, 3. Coordinate D is, which we find here is 1, 7. 1, 7. Coordinate A is negative 1, 4. Okay, so negative 1 times 2, you will get your answer negative 2 plus 6 plus 49 plus 4 minus of 6 plus 14 plus 3 plus negative 7. Okay, so equals to 57 minus 18. My final answer is 39 over 2 unit square. This is the last subtopic of this chapter, 7.4 Equations of Locus. In this subtopic, you have to know these two types of locus, okay? For the part 1, if I tell you this is coordinate A and this is coordinate P, the distance between coordinate A and coordinate P is 5. Okay, if let's say we use the formula of the distance. Distance between 2 points is equals to square root of x1 minus x2 square plus y1 minus y2 square. Okay, so the distance is 5 is equals to square root 5 minus x square plus 6 minus y square. So I can get my 5 minus x square plus 6 minus y square is equals to 25. So I will expand this. I will get 25 minus 10x plus x square plus 36 minus 12y plus y square equals to 25. After I rearrange it, I will get my x square plus y square minus 25x minus 12y plus 36 equals to 0. What does this equation mean? What does this equation mean? This equation means that every point in this circle fulfill this equation. Okay? For the second part, the question gives us coordinate A and coordinate B. It also gives us the ratio of AP and PB. So I know that the ratio is 1 over 3. So this is 1, this is 3. So I'm using the divisor of line segment. I can find the coordinate P. That means xy is equals to 3 times 3 plus negative 5 times 1 over 4 and 4 times 3 plus 6 times 1 over 4. You can find your coordinate P. But this is only the coordinate P. How can I find the equation when this coordinate P move to here? My ratio is still 1, 3. If this P move to here, my ratio is still 1, 3. I want to find this equation, okay? So no matter where this P move in this line, the ratio will be in 1, 3, okay? So I have to find the distance. AP over PB is equals to 1 over 3. So I will times 3AP is equals to PB. This is P. So I will write 3AP is equals to 3PB. 3AP, the distance between A and P is square root 3 minus x square plus 4 minus y square is equals to distance between P and B. So it's square root x plus 5 square plus y minus 6 squared. Okay, I want to take off the square root. I will square both sides. I will get 9. 3 minus x squared plus 4 minus y squared is equals to x plus 5 squared plus y minus 6 squared. Okay, so 9, here I will expect it become 9 minus 6x plus x squared plus 16 minus xy plus y squared. And here after I expand, I will get x squared plus 10x plus 25 plus y squared minus 4y plus 36. After I rearrange it, I will get 8x squared plus 8y squared minus 64x minus 60y plus 45 is equals to 0. So this equation is the equation of this red line. No matter where is the coordinates of P, it fulfills this equation. So this is what the equation of locus means, okay? Example 1, the distance of the moving point P from A is twice its distance from B. So the diagram will be look like this. Here is the A, 3 minus 4. Here is the B, which is minus 2 minus 4. And here is the P, which is x, y. Okay? The question says that point A is twice its distance from B. So here is 2, here is 1. Okay? So we know that PA over PB is equals to 2 over 1. PA is equals to 2PB. Now we can find the equation of the locus of point P. Okay? The equation of the locus of P is here. Okay? This is the equation. No matter the point P move, if the point P move to here, let's say the point P move to here, the equation still can be used. The ratio still 2, 1. Okay? Let's say the coordinate P move to here. The distance between AP and PB still in the ratio of 2, 1. Okay? So this is the equation of the locus P. Now we use the PA is equals to 2PB to find the locus of P. PA is equals to square root of the distance of PA is equals to square root x minus 3 squared plus y plus 4 squared is equals to 2 square root distance between PB. Okay, so x plus 2 squared plus y plus 4 squared. So I will square both sides become x minus 3 squared plus y plus 4 squared is equals to 4x plus 2 squared plus y plus 4 squared. Okay, then I will expand all this become x squared plus y squared minus 6x plus 8y plus 25 is equals to 4x squared plus 4y squared plus 16x plus 32y plus 80. So after I rearrange it, I will get 3x squared plus 3y squared plus 22x plus 24y plus 55 is equals to 0. So this is the equation of the locus P. Okay? Now the part B, you want us to determine whether the locus of point P intersect with the x-axis. So part B, when it is intersect with the x-axis, that means it is a x-intercept. Okay? When it is a x-intercept, that means y is equals to 0. Then I will substitute the y equals to 0 into the equation of the locus P. Then I will get 3x squared plus 22x plus 55 is equals to 0. This is the equation. Now I will use b squared minus 4ac to find whether the point P will intersect the x-axis. So the b is the coefficient b, 22 squared minus 4. Coefficient a is equals to 3 and coefficient c is equals to 55. And I will get my answer of negative 176, which is smaller than 0. Since it is smaller than 0, that means no real roots. Okay, so I will do the conclusion that locus of point P do not intersect the x-axis. Example 2. A cow moves at the end of a tightrope around the pole A as shown in the diagram. The cow passes through point B and point C. Part 1. Find the equation of the path of the cow. Okay. To start finding the equation of the locus of the cow, we have to have two information. The first information is the center of the circle. The second information is the radius. Okay. So we have the center of the circle, but we don't have the radius. Can we find the radius? Yes, because we have the 2 points, A and B. So distance between A and B is equals to square root 3 minus 0 square plus 2 plus 2 square. So the answer will be 9 plus 16, where is 5 units. Okay, so the radius is 5. Now we can find the equation of the path of the cow. Okay, so the equation will be square root of x minus the center of the circle, which is 3 square plus y minus 2 square is equals to 5. Because no matter how you move, your radius is 5. Okay, so x minus 3 square plus y minus 2 square is equals to 25. After you expand this, you will get x square plus y square minus 6x minus 4y plus 13 is equals to 25. Then rearrange it, become x square plus y square minus 6x minus 4y minus 12 is equals to 0. So this is the equation of the path of the cow. Okay? Now we find the value of P. So as what I said before, this equation is the equation of this circle. No matter which point in the circle will fulfill this equation. Okay? So the equation here C, point C is 0, P. So the x is equals to 0, the y is equals to P. So I will substitute x equal to 0 into the equation. From 0 plus P square minus 0 minus 4P minus 12 is equals to 0. So my P square minus 4P minus 12 is equals to 0. I can find my P by using factorization. P plus 2, P minus 6. I can get my P is equals to negative 2, P is equals to 6. Now I have to determine what is my P. Actually, you can know that this is the y-axis. So since here is negative 2, so here is 6. Alright, so as what you see, you can get your negative 2 and 6. So your P is equals to 6. Example 3. The point A, B and M lie on the circumference of a circle with diameter AB. Find the equation of the locus of the moving point M. Okay, so AB is the diameter. Okay, this is the diameter. So the equation of the locus of the moving point M. So M can be at here. Okay, M also can be at here or here or at here. I don't know where is it. Okay, so I have to find the equation of the locus of M. To find the equation of the locus, we have to know two things. The first thing is the center of the circle. This is the first thing that we have to find. And the second thing, we have to find the radius. This is the second thing that we have to find before we can find the equation of the locus. So now I will find the midpoint of AB. Okay, so midpoint of AB is equals to 1 plus negative 2 over 2. 3 plus negative 4 over 2. So I can find my midpoint is negative 1 over 2, negative 1 over 2. Then I have to find my radius. I will find my length of AB. My length of AB is square root negative 2 minus 1 square plus negative 4 minus 3 square. So my answer will be 9 plus 49, which is equals to 58. Okay, square root of 58. Then I know my radius will be equals to square root of 58 over 2. Okay, I have first information, I have my second information. Now I can find my equation of the moving point M. Okay, so my equation of moving point M will be square root x plus the midpoint is here. Okay, the midpoint is negative half, okay, x minus the negative half square plus y minus the negative half square is equals to the radius, which is square root 58 over 2. Okay, so I will square both sides, become x plus half square plus y plus half square is equals to 52 over 4. Now I will expand this, become x square plus x plus 1 over 4 plus y square plus y plus 1 over 4 is equals to 58 over 4. After I rearrange it, I will get my final answer is y square plus y square plus x plus y minus 14 equals to 0. So this is my equation of the locus of the moving point M, no matter where the M is. Okay? I have finished this chapter. If you found my video is helpful for you, please do share to your friends. See you in the next chapter. Bye!